Have you ever found yourself lost in the mesmerizing world of fractal animations? Wondering just how those intricate patterns come to life? Well, buckle up, because today we're diving into the captivating realm of Newton's fractals. Hello everyone, welcome to Voxel's Animation. Imagine you're trying to compute the value of some mathematical constant, and while playing around with its properties, you discover that you can express it as the root of a certain function. And here you ask yourself an important question. Is there some iterative method that would allow me to slowly close down on its value? It turns out there is, and it's called Newton's method. Starting with an initial guess and using the formula on the screen, it allows you to converge towards the root of your function. But hold on. What would happen if our function has more than one root? Let's try with this example. It would seem like the process has converged to one of the roots. Let's try again, with a different initial guess. This time, the algorithm has picked another root. Now another question we might be asking is, does this process always converge? Let's test this with this example. This time, the algorithm clearly diverged. So keep in mind that this method does not always converge. Let's go back to our original example. Let's spice things up by applying Newton's method to the complex plane. We can clearly see the two roots of our function. What do you think will happen to all these points when we apply our method? Almost all of the points converge to one of the roots. I intentionally left out points lying directly on the imaginary line because this process does not converge for them. Now, we color every point depending on its landing position. Let's repeat this process with another function, this time with 3 roots. Again, we color points depending on their landing position. This figure is perhaps the most famous of all Newton's fractals. Let's try to vary the exponent in the function's formula. What do you think will happen? Let's repeat this one last time for the cosine function. Let's add a complex variable to our formula. To generate our animation, we will make it vary across a path on the complex plane. Now you know all the magic behind these animations. If you want to learn more about making animations using math, you can subscribe for future videos or watch this video next.